Hello everyone, I'm going to do a TinkerPlots demonstration of the kissing the right way activity. This is an example of how to compute a confidence interval for a proportion. So my first step is to get a sampler. We're going to simulate the sampling of the kissing study. So here's the spinner, and we're going to just draw one. And this is going to be right, and this is going to be left. And let's call this couple, or you can call it kiss, or whatever. And I'm going to show the percent, and the percentage is going to be the percent you calculated from the initial study. So there were 80 couples that leaned to the right out of 124. So that should be 64.5%. So you can change that. And the left will adjust automatically. So I'm going to change this to fastest, and then since we have 124 couples, we're going to change this to repeat to 124. So that simulates our sampling, and we're going to run this. This simulates one sample of 124 couples, and we have a plot, and we'll split up the left and right. And we're supposed to collect the percentage of couples who lean to the right. So I click on the percentage and then click on this 65 here. It might be different for in your case, this is a random sample. So we collect the statistic, and then we're going to do this 499 times. But first I'm going to collapse the plots so that I can turn off the animation. So once I do that, I go back to the history of results table, object, inspect collection, and then uncheck the animation. Let me do this 499 times. So this simulates collecting 500 samples of 124 couples each. So we plot the collected percentages. And this is called a bootstrap distribution. It simulates the sampling of 124 couples and doing this 500 times. The center should be pretty close to your what you set the sampler proportion to be. So we set the sampler to be 64.5 to the right, and then this is 64.29, so it's pretty close. It's not going to be exactly the same because we only have 500 here, but it should be pretty similar. So the next step what we want to do is get the standard error. And so we go back to our case table of history of results, and then make a new attribute called standard error. So we right click and edit the formula, and we're just going to get the standard deviation, because remember the standard error is the standard deviation of your sample statistics. So we use the std_dev formula, open the parentheses. It should turn blue, that means it's working properly. And then inside the parentheses you want your attribute name. So under attributes you can click on the, or double click on the percent couple right here, and then OK. And so your standard error is 4.19, roughly 4.2. And so this is what you're going to use to calculate your interval. I'm going to do it in a text box here so you can see it. So our interval estimate is always our observed statistic plus or minus 2 times the standard error. So our observed statistic, we know it's the 80 out of 124, which is the 64.5%, and then plus or minus 2 times the standard error of 4.2. And so once you do this, if you take a calculator and just do 64.5 minus 2 times 4.2, you should get 56.1%. And then if you do it the other way and add the 64.5 plus 2 times 4.2, you should get 72.9%. So your interval might be slightly different just because since my sample of 500 might be a little different from your sample, you might get a slightly different standard error, but it should be pretty close to this at least. And so this is your interval estimate of the percentage of couples that lean to the right. You can do this with not just with sample percentages, but you can also do this with means. So if you're trying to estimate a mean, you could collect the mean 500 times, get the standard error, use the same formula here to compute the interval. So you can do this with other things besides percentages. But this is a demonstration of how to compute a confidence interval with percentages. And so to interpret this interval, we say that we're 95% confident that the true proportion of couples who lean to the right from this population is somewhere in between 56.1% and 72.9%.